In this section, we are going to cover very interesting theorems, which are very powerful and very useful for our course. The first one is called Wilson's theorem, which is one of the very famous theorem in number theory. And it says, if p is any prime, then p minus 1 factorial is congruent to negative 1 for modulo p. Let's prove it. First of all, if p is 2, then p minus 1 factorial is same as 1 factorial, which is 1. And for modulo 2, 1 is same as negative 1. So it's easy. For any prime which is greater than 2, let's keep that one in your mind. P should be an odd number, right? Okay. Then if you choose any number between 1 and p minus 1, because p is a prime number, so any integer between that should be relative prime with p. So we know there is a unique inverse which can be written by a bar, should be also between here, and the product must be congruent to 1 for modulo p. And another thing is, from theorem 41 in sections 1.7, 1 and negative 1s are the only integers that are their own inverses, and negative 1 is congruent to p minus 1 in modulo p. So 1 and p minus 1 are they're its own inverse, right? So from this fact, if you just choose any a between 2 and p minus 2, because 1 and p minus 1's already their own inverse, right? So let's just ignore that. Then if a is any integer between 2 and p minus 2, then their inverse must be also between 2 and p minus 2. So we can actually regroup these integers from 2 to p minus 2 into that many pairs of integers, and their product of each this pair must be congruent to modulo p. So how about 2? If you choose 2 between there, then there is inverse of 2 in the same range, right? We don't know what that number is going to be. It depends on the modulo p, but we know, we can be sure that there is such inverse, and it should be unique. And another thing, p is a prime which is greater than 2, so it should be odd number. So minus 3, because there are only p minus 3 integers in between these two integers, right? So this number should be an even number, right? So after divide by 2, it's going to be another integers, right? So it's well ordered by these two the evens, right? Each pairs, right? So all integers could be matched to its own inverse, which is not known at this moment for general p case, but we can guarantee that all this multiplication starting from 2 to p minus 2 should be congruent to 1 for modulo p, because 2 has its own inverse here. So 2 times that number becomes 1, 3 times its own inverse in there is another 1, like that, right? So all this multiplication should be congruent to 1 for modulo p. So p minus 1 factorial means 1 times 2 times up to p minus 1, but we just checked this multiplication becomes 1, congruent to 1, right? And 1 times p minus 1 is p minus 1, and p minus 1 is congruent to negative 1 for modulo p. And that's what the Wilson theorem says. Please keep this in your mind. This congruency is true when only p is prime.